Good morning, everyone. Welcome to my class, our virtual mathematics class. So our lesson for today is all about arithmetic sequences. So for our objectives for today's lesson, you will be able to, letter A, illustrate an arithmetic sequence. Letter B, determine arithmetic means and end term of an arithmetic sequence. And letter C, appreciate the importance of an arithmetic sequence in real life. An arithmetic sequence is a sequence where each succeeding term is obtained by adding a fixed number. The fixed number is called the common difference, which is denoted by D. To find the next terms in an arithmetic sequence, we use the formula. A sub n is equal to a sub 1 plus the quantity n minus 1 times d, where a sub n is the last term, a sub 1 is the first term, and your n is the number of terms in the arithmetic sequence. Now let's have illustrative example number 1. Study the given examples below, then identify if it is arithmetic sequence or not. For letter A, 10, 13, 16, 19, and so on. Is it an arithmetic sequence or not? Okay, let us see. So to find out if this is an arithmetic sequence, we must be able to identify or find if there is a fixed number added. How is that? So to see if there is a common difference, we will be subtracting the preceding term from the succeeding term. How is that? So since 10 is your a sub 1, 13 is a sub 2, that will become a sub 2 minus a sub 1. So meaning to say that's 13 minus 10, which is equal to 3. Next, 16 minus 13 is equal to 3. 19 minus 16 is equal to 3. See? There is a common difference of 3. Again, there is a common difference of 3. Yes, so meaning this is an example of an arithmetic sequence. Letter B. We got 2, 6, 18, 54, and so on. As this is an arithmetic sequence, let us see. So 6 minus 2 will give you 4. 18 minus 6 will give you 12. So from that two differences, we don't have common. So meaning to say, this is not an example of an arithmetic sequence. Is that clear? Okay, very good. So for letter C, we have 57, 49, 41, and so on. Is this an example of an arithmetic sequence? Let's find out. So 49 minus 57 is negative 8. 41 minus 49 is negative a. Meaning, there's a common difference of negative a. So this is an example of an arithmetic sequence. So for illustrative example number 2, determine the 10th term in the sequence 4, 6, 8, 10, and so on. Okay. If you're going to look at the sequence, the first term here is 4. So that is a sub 1, which is equal to 4. So let us verify if we have a common difference. So 6 minus 4 is 2, 8 minus 6 is 2, 10 minus 8 is also equal to 2, meaning the common difference is 2. So since we are finding the 10th term, our n is equal to 10. Let us continue. So for us to find the 10th term, we will be using a sub n is equal to a sub 1 plus the quantity n minus 1 times the common difference. Now, since our a sub n, or what we're finding here, is the 10th term, our n is 10. So a sub n now becomes a sub 10 equals, the first term is 4 plus our n is 10, so that is 10 minus 1 times the common difference of 2. Let us continue. So our a sub 10 now is equal to 4 plus, what is 10 minus 1? Very good, that is 9 times 2. So 9 times 2 is 18. So therefore, a sub 10 is equal to 4 plus 18. So your 10th term now is equal to 22. Yeah. So therefore, 22 is the 10th term of the arithmetic sequence. Is that clear? Let us proceed to arithmetic means. What are arithmetic means? The terms between any two non-consecutive terms of an arithmetic sequence are known as arithmetic means. Now let's have illustrative example 3. Find two arithmetic means between 2 and 8. Okay? Now for the solution, we must be able to clarify how many terms are there to be inserted between 2 and 8. So it's clear that we need to insert two arithmetic means. In other words, since our first term is 2, the two arithmetic means or unknown means are a sub 2 and a sub 3. So clearly, we have 4 terms in our sequence. Let us continue. So using a sub n is equal to a sub 1 plus the quantity n minus 1 times the common difference. Since our last term is 8, so that will be substituted from our a sub n. So a sub n now becomes 8. So a sub 1 is 2 plus, how many terms are there in our arithmetic sequence? Very good. There are 4 terms. So n is equal to 4 minus 1 times the common difference. The idea here is we must be able to find the common difference in order for us to add this fixed number from our preceding term, in order for us to get a sub 2 as well as a sub 3. Alright. Now, simplifying further, 4 minus 1 will give you 3. So what is 3 times d? 3 times d is 3d. Very good. So we have now 8 is equal to 2 plus 3d. Now, for us to eliminate 2, we can add both sides of the equation by negative 2 or simply subtract both sides of the equation by 2. So we have now 8 minus 2 is equal to 2 minus 2 plus 3d. So that is 8 minus 2 is equal to 3d, since 2 minus 2 here will give you 0. So simplifying further, 8 minus 2 is equal to 6 equals 3d. To find the common difference, we can multiply both sides of the equation by 1/3 or simply divide both sides of the equation by 2. So therefore, we have now b is equal to 2. So this common difference will be added to the first term in order for us to get the second term, and after getting the second term, add again by 2 to get the third term. Yeah. So meaning, if the first term is 2, so that is 2 plus 2, very good, the answer is 4. 4 now is the second term, and 4 plus 2 is equal to 6, which is your third term. So therefore, the numbers 4 and 6 are the two arithmetic means between 2 and 8. So we have now 2, 4, 6, 8. Okay, is that clear? Okay, very good. So don't forget that honesty is the best policy. So thank you for listening and happy learning.